Welcome back to the Winner Circle, everybody. Today, cool uh, podcast episode here. We're talking about the EV and market and what's really limiting adoption and limiting growth. And we have Alex on here today from XCharge. He is a big innovation award winner. So welcome, Alex, to the Winner Circle.
Thanks, Russ. Thanks for having me.
Now, everybody's talking about EV adoption, but very few people are talking about the infrastructure and the capital and all the work that really goes into making this thing work. And you are building all of this into one platform. So why don't you give us a little bit of an elevator pitch about XCharge and tell us what you're doing?
Yeah, most definitely. So XCharge, we're a manufacturer of EV charging and energy storage solutions, and specifically XCharge North America, really geared towards the North American market. XCharge Group as a whole, we've been operating for nearly the last decade, and have a presence in over 30 plus countries to date, predominantly focused on the EU and North American markets. The platform we're excited to talk to you about today and tell the viewers about, and what we received recognition for the innovation award, or big innovation award, is GridLink, which is our battery integrated DC fast charger. It's a bi-directional unit, meaning you can take energy into it and export energy back, take solar direct into the unit, and charge cars up to 300 kilowatts output. We can go into all the specifics of what that means and do the whole breakdown of energy transfer. But the really cool piece of technology in there is that we have integrated a 215 kilowatt hour battery, flexible up to 430 kilowatt hours, where we can take energy from the grid, store it in the battery, use that to buck boost output to vehicles, meaning that when grid limitations are there, we can start to use that to help get more cars on the road and moving faster.
Well, this is, I think, the big, it's one of my big pauses for EV is, you go around the shopping malls around where I live and you see, there's a line of five cars deep just to get to the charger. And then you've got to sit there for 20 minutes. And, as an ADD person on the go, I'm looking for that experience, just like a gas system, right? Where I pull up, I charge and I refuel and I move on. Um, so walk us through kind of why the charging infrastructure is harder to scale than what people expect.
Yeah, most definitely. So you've probably heard it time and time again, but one of the biggest limitations on getting EV infrastructure on the ground really is the grid. And that reflection of it being the grid can be perceived as a few different ways, but predominantly it's that we don't have enough power in every single area to power high-speed chargers without pulling a new service, dropping a new transformer, upgrading what we have going on there to bring more, high power voltage to site in places that typically wouldn't have that. It's a costly procedure. Utilities like to do it because it means they're going to be locked into paying that rate for a good time, but they have to organize the labor in order to get out there, so that takes time. Sometimes when we work with customers, we'll see up to 52-week delays, on maybe even up to 72-week. You can have up to like a year and a half that you're waiting for the transformer, for the utility to be able to pull out service that area, and then you might get dropped in the queue dependent on how big of a build you are, who you are, if there's a data center that might be coming up that needs to allocate a little bit more in that nodal center. So this has been a major focus for XCharge North America since we got up and running. I'm one of the co-founders of the company, the North American subsidiary, along with my business partner, Atish Patel. And, we started out actually in the hospitality market. We identified that hotels and really most commercial locations have ample supply of energy, at least from the perspective of what they have capacity-wise for air conditioning units and that general buffer zone that they would need within the building. But the difficulty is that they don't have 483 phase service. And this is where it starts to get a little bit technical in terms of the understanding of the electrical grid, but I'm obviously happy to break that down.
Yeah, well, tell us what 483 is in layman's terms.
Most definitely. So 483 phase it's a type of high power voltage. It's a type of three-phase architecture, or voltage architecture, that you find commonly on sites that are dedicated for high power usage, right? You'll find it maybe in industrial shops like CNC machines. You might find it in other heavy manufacturing industries. You might find it in some places that have like large power refrigerants, but it's generally not something, even in the case of large building systems. Like, I live in New York. you don't really find 480 just rigged up to a building. It's not as common. The process is actually stepping down from the utility service line and stepping that down to 480 three-phase. Whereas what we commonly find 208 three-phase is generally stepping up from what we have in our house. A 120 base, single phase base architecture, 240 split phase. And then when that comes into a triangle delta, you get 208 three-phase. Still a high voltage application, still can output high power, but there are limitations based on what it's going to mean in terms of amperage increase. And this is just, again, it goes quite technical in that way. But what we ultimately recognized is we need to find a better way to get electric vehicle infrastructure in place in places that make sense and start to break down this paradigm of site and purpose, right? It's great to roll up to the shopping center and, there's obviously an opportunity there with a lot of parking space to have more charging. And it makes sense for the user to be there ultimately if they're going inside to shop. But when that is your only dedicated place, that isn't for every driver. Opportunities for charging and really anywhere you want to be. Say you have a haircut, having a charger in the strip mall that's nearby the where you're getting your haircut, or the Indian restaurant that you're going to have dinner at for 45 minutes to an hour. When you start to think about pairing activity along with your charging schedule and it becomes part of the routine, that's nice. Now, interstate travel, whole different side of the equation. When you're trying to visit grandma in Ohio and you're planning to power drive for 8 hours straight, yeah, I can understand when people get frustrated that they might need to wait in line for 20 minutes and then a 30-minute charge cycle. And then next thing you know it, you've waited there for an hour and you've increased your entire transit time, to 9 hours or perhaps 9.5 hours if you have to make another stop before you get to her. But, in most daily applications, charging at home is very viable. Public infrastructure is also very viable when you plan for it, and even in long road trips. But you just need to be knowledgeable about that. We're getting towards a place where higher speed outputs are very feasible. Cars are starting to take higher charge rates, but it is also this continual balance between what cars can take and what we're putting onto the grid and what our general infrastructure is. So that's where we come in, and the solutions that we design.
Well,
Um,
it's
yeah,
not unlike the kind of the smartphones, right? As we have, superchargers for smartphones, and you plug them into a regular port and it's slow, and you need a faster charger, a different type of device to charge. And I don't think everybody's used to that yet. But my experience with EVs is, I rented an EV by kind of mistake, or I guess I got put into an EV as a rental, used it all weekend, and then literally headed back to the airport and had no idea what to do with it. And I dropped it off nearly empty because where I went didn't have a charger, and I wasn't about to go try to find one. So I took the $20 hit or $50 hit or whatever I took. And I think that's the real challenge. Is it's got to be just as pervasive, like you're talking about, as gas.
there's this idea that I've continually spun on with folks, which is the idea of perceptive availability of charging. When we often go around this conversation of EV adoption in the US, there's this chicken and egg scenario. Do you help your customers understand the opportunity there is in charging for the next 5 years? But when you look at utilization today and you read all of the news and, a lot of the negativity around EVs and EV adoption and look at the adoption rates being slower than what we had anticipated in some cases, but also faster in some cases, depending on the quarter that you look at it, and what the manufacturers are doing and what incentives there are, in the long run, it's still a great opportunity. But it's needing to get this perceptive availability of chargers up so that EV adoption does increase. And it seems kind of backwards. Obviously, I have a horse in the race because I sell chargers and I manufacture them. But at the end of the day, it still is a characteristic of, well, you don't think about where you need to put gas in your vehicle because you know that anywhere you drive, there's going to be gas. So it really needs to get to that where, driving an EV, you don't have to think about where you're going to charge your vehicle because it just makes sense and it is in the areas. And I mean, I can say firsthand, I've done a ton of road trips up the East Coast, a little bit of planning ahead of time. PlugShare makes it very easy to put in your route and understand what chargers there are on the way. I generally pick two that are within like the 20 to 30-mile variants that I'm planning to be down to like 20% of my battery because that's your optimal charge point is going at 20% up to 80%. in any situation. But try to time that out so there's a little bit of variance in between. And then, if you drop down to 10%, you sweat a little bit, you turn off the air conditioning and, just kind of cruise your way in to make sure that you can get juiced up faster.
And there's been plenty of times people talk about range anxiety, and as a teenager, I remember having, gas anxiety too, and pulling into a couple stations on fumes. So it's on both sides. It's just as you talk about it. I think as we get more pervasive with chargers, we won't have as much range anxiety. Now, you mentioned something earlier that's kind of near and dear to my heart is these AI data centers and data centers in general. Their whole model is following kind of the charging model, which is get out closer to customers because they want data closer to customers. You guys are now competing on the grid with that. Where do most deployments break down? Is it technology, permitting, financing, or grid limitations?
Definitely, financing and permitting are probably the yeah, two categories that cause the most delay in projects, generally make it where it's going to break down. Power availability is, a part of that equation, because often you're looking at it in a characteristic of when you're selecting a site, you want to make sure that there is power availability, that you can get the power request from the utility company, or if there's a method to cut that queue. In some cases, when you integrate energy storage into your overall architecture, you can start to cut the queue based on not needing as much power from the utility company, and they're a little bit more flexible as far as where they can slot you in. So we often find that with GridLink, the unit that we're super excited about and really has a direct application for North America, the ability to have a 215 kilowatt hour battery and then flexible up to 430 kilowatt hours, planted at the site of the charger allows for a lot greater flexibility. And we've seen this use case in fleets and, depot charging. We have an upcoming project in Brooklyn for 44 grid links, which is nearly 10 megawatt hours of energy storage underneath the Williamsburg Bridge. And super excited about that. But what makes that super unique is the power request is not nearly 10 megawatt hours, or not nearly 10 megawatts of what they need for the interconnection. They're going to need closer to four or five for a max intake off of that unit. So it's just a very interesting situation to be able to put into.
So explain this kind of role of the battery integrated system. I think this is new to me. I was thinking, they're plugging in power and you're doing your DC AC conversion voltage, whatever, stepping it down from that big pipe into little pipes into the cars. Explain the role of that battery integrated system.
Yeah, most definitely. So a general DC fast charger is, as you mentioned, Russ, like going to take power in and then just dispense that power out. Every DC fast charger is going to have power modules in them, which generally are their AC DC modules. So you're going to take AC, alternating current from the grid, and then dispense that as direct current out to the cars. Um, Cars have an onboard, this is probably not really relevant to this conversation at all, but just an interesting nerdy bit. Cars have an onboard AC DC converter, but it only works under effectively 11 kilowatts, generally like 20 kilowatts is that range. And that's where you take an AC charger where your level 1, level 2 that you can have at your home or specially equipped at your home or workplace, whatever it might be, put that into your car and it's going to do the conversion there. Once you start to get into higher power output, when you're going into direct DC, that's where you have the specialized plug type where you have a CCS1 plug or an NACS plug. And that's going to allow for the power transfer working with the charger itself. We manufacture both types of chargers. We have just straight direct current chargers. We don't manufacture AC chargers anymore. We started out in that as a product line and then sunset that back in 2019. But our DC fast chargers are unique in that we can take 208 three-phase, like I just described before. We can take 480 three-phase. And then we also have our battery integrated solution. The battery integrated solution is especially unique in that we're able to take power from the grid and also dispense power from the battery at the same time, either to work in parallel to dispense out to the vehicle or to capture into the battery while discharging to the vehicle. So that way we can keep a constant flow of energy coming into the battery. We can cut off any usage from the grid, or effectively we can tailor whatever energy usage we want from the grid dependent on local utility rates, whether there's demand charges, whether we're dispensing during peak hours, or really just having the ultimate flexibility for what your energy management needs. That will reflect back on an impact to the output to the driver. But if the driver knows that, you know, they aren't going to get that amount, this is all comes back down to an education or or understanding and transparency with them and understanding what their charge rate should be. You know, it's negligible as far as the impact goes. We've run
So
tests. Yeah, go ahead.
go ahead.
Yeah, yeah.
Well, when
No,
you
no.
integrate one of these battery systems, I imagine that speeds the deployment. What does that look like in in the real world?
Yeah, yeah, no, it speeds it up quite significantly. So where I was mentioning there's a 52-week lead time often in getting a transformer drop, you know, hardware from the DC fast charging perspective is less so the constraint in that use case. You know, you're generally timing it around when you can get the transformer drop. A battery integrated charger like GridLink, we can get projects in as fast as the permitting can get done often. If power is available on site and we're able to tap into that, then so long as we can get the CDs in and go through the permitting and get through all the permitting considerations, then generally we can get it up within 3 months is about the timeline we've been seeing for a lot of GridLink projects once they're ready to go.
Hmm. Now, you mentioned capital is kind of a core part of the equation too. Why is financing such a critical piece of the infrastructure growth? Why is it so challenging?
Yeah, yeah, I think you know in this industry, it's really come down a lot to understanding utilization. And like I was saying before, with this chicken and egg predicament, you do come into, an instance of it's very hard to pin down utilization on a charger over the long run. So depending on the total cost of ownership, how much you're paying for the charging hardware, the service, the labor, your utility costs, all of these overhead costs that attribute to the actual project cost, and that's just your money out, and then the ongoing operational costs that you need to consider, it starts to, and when you model it out, it starts to make it very difficult to think about who's backing that. When we see independent developers, we will see instances where they have a great site, they, have figured out the tech stack, but they don't have the capital underway, and they can go to get a bank loan, but maybe the bank isn't as comfortable on that traditional financing method. They don't want to take debt on that. You have some instances where people will raise capital to go out and deploy chargers, but then you're in the unknown that once your cash is out, you're not working with it too much. We've worked internally. We have a few financing mechanisms for equipment financing that we work with to enable that, effectively to close that gap of capital cost for folks. Thinking about it on a monthly cost for what they're going to generate and based off of data that we have of generally about what they can make on a charger. But it's all going to come down to site specifics and how it operates there. But the main things that effectively people want to hone down on for determining that cost is obviously the cost of your equipment, your charging hardware, the cost of the utility service and pulling that in, whether you can get incentives to help close that gap from a make ready perspective. Then your ongoing operational costs, so what your utility rate is going to be, and whether you're facing any demand charges. Demand charges are something that's going to really throw the equation out of whack.
And sorry,
Yeah,
explain demand charges. Is that paying more at peak hours?
exactly. It's paying more at peak hours, and in some utility tariffs or in some utility jurisdictions, it may be that if you exceed a certain rate that you're supposed to have on site, if you exceed that at one point for 5 minutes or any point during the month, you might end up paying up to that new rate amount for the entire month. Which in that situation you can pay up to 80% more than what you're expecting to pay, and then your model goes from we were going to ROI in 3 years to now, oh, every time that happens, we're pushing it out 3 months and 3 months, and then it becomes difficult.
Well, there's a direct parallel to the bandwidth industry, which I've been in for decades, and we have peak hours too. I wonder if they're the same. We'll talk about that in a minute. Peak hours in telecom, where when kids got home until through 10 o'clock or 11 o'clock, basically when people went to sleep. And, the telecom operators and bandwidth operators used to, look at that of like, can we charge more during that? Or what do we have to do? And ultimately they decided they couldn't. Here you're talking about a limited capacity. Bandwidth is somewhat of a limited capacity, but they can just add more. It just costs more. How do you think about ROI when you're deploying these charging networks when you have all these variable costs?
Yep. So it comes down to a good model and understanding kind of your inputs as well as controlling the variables as much as you can. So we help guide our customers through that in many cases. as far as understanding um, how much it's going to cost to deploy, and then what they're charging for each session. Generally, looking at like a 40 kilowatt hour session is general basis that we're going to look at that on, and then obviously time of day, how much they're paying for electricity, and then just modeling that over time. We take a pretty conservative approach to what we pin for utilization expectations, mainly under the context of we would like to aim low and earn higher. So if we can help get somebody to an understanding that they'll ROI within 2 to 3 years, that's a really good situation. And that's generally kind of about where we'll look at it.
We talked about grid capacity as kind of one of those issues too, and we were talking before we started recording about Singapore and Northern Virginia literally being out of power. And now we're spinning up nuclear sites, dormant nuclear sites to really feed the AIs. How are you solving for this grid capacity issue?
Yeah, 100%. So the benefit of having a 215 kilowatt hour battery, flexible up to 430, and the ability actually to take solar direct into the unit, which we didn't even mention off the onset, but
Mm.
GridLink can take up to 60 kilowatts of solar direct into the battery via DC-DC connection, meaning less efficiency loss on that front. Um, and via onboard MPPT modules, which which are maximum power point tracking modules. Effectively, what that means is that if you have a 70 kilowatt array and you hook it up to our battery, you can only take a maximum of 60, but it will ensure that it takes 60 based off of which cells are capturing the most energy and help to aggregate that in its string, as opposed to before when you would need to have it really 1 to 1 if it doesn't have MPPT modules on it. Most solar inverters are going to have that nonetheless. But from the aspect of energy availability, when you can stack solar on top, when you have battery capacity that then you're placing in nodal centers, and the ability to dispense that back because the modules we're taking into the battery also are capable of distributing back to the grid. That means we can help power buildings during blackouts. We can help provide power back to the grid as a whole in situations where there's demand response events and deregulated energy markets. And that's really the hope of adding additional benefit on top of just EV charging. What's been hard in the capital stack of EV charging is that it's a straight 1 to 1 purpose, right? You install a charger, it's so that you can make money off of electrons that you're vending into vehicles. There's no ulterior benefit that's going to the building. There's nothing that you're going to be able to take from a power consumption standpoint, help offload any peak demand from the building itself also, which are all feasibly capable things that GridLink can help accomplish. And that's what we're very excited about from the product standpoint. Where it comes into now is the product is capable of it. We're testing it in certain jurisdictions and various deployments of ours. But then from a wider adoption standpoint in the US, that will take some time to just get utility companies comfortable with having more discharge back, more batteries on the grid that are able to do this, and not batteries that are built in such a large scale way that we've been seeing in many deployments where it might be 50 gigawatt hours or 50 megawatt hours rather, up to 150 megs, maybe 200, in some cases going up into the gigs. So like once you start to get into that threshold, you're playing with a different ball game. But we see a lot of promise in this like nodal center idea of collect energy, be able to distribute it back there when it needs it, and the uptake rate is pretty fast.
Oh, it makes all the sense as a building owner, as a property owner, is you're, you're not only improving the amenities of that space and maybe earning income off that space, but also providing amenities back to the other buildings or, tenants in that space. You mentioned 60 watts of solar as a unknowing being. How big is a 60-watt field?
Yeah, 60 kilowatt array is going to be, I want to say, ge- generally like uh, maybe 12 carports
Oh,
length. So
okay.
for example, we have an installation out in Pendleton, Oregon with a customer of ours, Arrowhead Travel Center. Really cool build. They have a 40 kilowatt array that's feeding into 4 grid links, and that's taking up about 8 spaces via a carport. So yeah, at a 40 kilowatt array, and then you extend that out a few other spaces. Yeah, you'll look at probably 14 to 16 spaces probably on that
Okay.
type of
I
setup.
was thinking
Yeah.
fields and fields, but that seems pretty efficient and pretty doable.
Yeah.
Given what your typical charging station looks like, it looks, if it's a gas station-esque footprint, that doesn't seem unreasonable at all.
It is the ideal method, right, for EV charging. Well, like when we think about it, what is prettier than a solar array up top, capturing that and that actually going into the charger that you're dispensing? But in practice, it's not always one to one for what can be accomplished in its current form in the industry. There aren't many units that are capable of taking DC direct in. There's not many units that are capable of balancing that energy management from the solar. So then you have to bring in outside software that's going to help balance that out. You might have to have a microgrid controller that's doing everything. You're going to have external batteries, and then that's not even talking about any of the efficiency loss that you're seeing from the energy transfer standpoint. Um, Going conversions AC to DC, DC to AC, DC to AC, AC to DC, and back and forth all this time, you're losing percentage points that effectively you're like, it's like when you have a hose that's either condensation leaking out the side, or if it's just a leak in your hose, you're effectively dealing with that. So
Any conversion point in any network it's where the loss happens. I was in telecom again, and every conversion from Ethernet to fiber, you had a loss of energy, a potential loss of data, and you had to equate for that. It was it's part of the equation. When you're scaling these up, what surprised you most? As you start these kind of larger deployments.
I've been really intrigued by some of the use cases that we've come across, and how folks are able to think about balancing the energy load. I think one of my favorite use cases that we've been able to work closely with our partner Gateway Fleets on, is that they integrate GridLink into their fleet depot management. So they lease vehicles to local transportation, or not local transportation, but like LTL, less than load or localized delivery vehicles. They'll lease vehicles to them and then also offer a place for them to charge. But in thinking about the vehicle load that they have out in the field, they need to think about the charging schedule. And they're able to use two GridLink units with 430 kilowatt hour batteries on them. That's the dual battery variety. And they're able to balance that load from what they know the car is going to need to take when it comes in, optimize the charge time and the charge cycle. So it maybe hits a driver's lunch break and that they can get back to 100, or maybe it hits a few in series overnight that they know that they can cycle in and out. Maybe don't need to dispense full load, and then they're in one of the most challenging utility rate regions in the nation, out in California. So dealing with how they're balancing peak demand and making sure that they aren't going to go over that threshold and start to pay out extra money that they hadn't attributed for. So it's a really interesting use case of in the fleet depot perspective of how folks use that, which often when folks first look at batteries, they don't want that because they're afraid it's going to be empty. But when you truly can balance your methodology, it makes a lot of sense. Um, and then I think like from the other surprises that we've seen in the field, how I think once we've talked more with utilities and gotten them comfortable around the idea of what this unit can do, they get pretty excited. We work with Orlando Utilities Commission down in Orlando, and they were one of our earlier customers of the precursor unit Net Zero series, which is what led into GridLink, another battery integrated unit. And they see a lot of promise in the ability to use that as a way to tack on or bolster some of their own infrastructure. And when you start to see some of these people or some of these companies, not people, but entities understand the benefit that batteries integrated with chargers have for the grid at large, it's very interesting to see some of that adoption. So we're hopeful to take that forward a little bit more.
Well, and we're seeing that in data center development too. As they're deploying, a lot of municipalities are mandating kind of local generation and local storage, and so that's becoming a big industry in that market too. And you all are fighting for the same resources. So, and
Hopefully we can help them out. That's my hope, right? Is like
yeah.
ideally that this is kind of where I see is the energy mix, right? They're going to need to find other supplemental forms of energy and coming into there. They are starting to implement batteries, but the batteries that you often find in a data center actually aren't that massive because they're going to have cold start generators that are going to need to do the bulk of the energy generation on any sort of resiliency use case, but they need the battery in there as a kickstart, something that keep the load going before or to get that energy into the generator just to get that up and going. So when you have that plus charging associated at a facility, perhaps for some of the like fleet vehicles they might have locally or even employee vehicles and the optionality to charge there, especially if their energy mix is cheaper because they're pulling in solar because they've developed that themselves and starting to take more offtake that way, starts to the wheels start to
Yeah.
turn a little bit more of what's feasible.
Well, you mentioned you had some success with a fleet. As EV adoption grows, where do you see the biggest opportunities? Is it urban or fleet or commercial?
I think right now fleet has been the biggest mover on that, and at least kickstarting some of that wider adoption. We've seen a lot of momentum from company fleets transitioning electric. We've run the numbers alongside with some of our customers of what the total fuel savings costs look like, and you see a reduction of nearly 30% about on like overall long-term maintenance costs and fuel costs of that side, and especially, I mean, I haven't run the numbers since recent gas prices, but I'm sure that that would have an even bigger uptake on what that might look like. Probably should go back and rerun some of those. But you see that as a major point. We're very hopeful, not hopeful. I mean, we already see it, but we're very optimistic about the commercial side too. As more cars get on the road and more independent business owners, landowners start to see the opportunity around charging, that they will be the ones to start to take that on. But until then, that gap is being met by, business operators who lock in leases, see the real estate, understand the opportunity, and want to take the risk and put that in. And we love working with those folks that are thinking creatively about those solutions.
You mentioned something earlier that kind of struck me, which is these charging stations are really becoming part of the larger energy network, part of the grid. How is that going to kind of, change how we operate these grids long term?
I think it's all a moving target right now for how we think about the how the grids are operating long term. Um, we have seen an incredible amount of change of how people interact with the grid. I mean, when you think about it, this is one of my favorite stats. Is generally a household is consuming about 24 kilowatt hours a day. A car is going to consume generally more than that. So when you start to bring that into the equation, just purely on the residential factor of people starting to charge their car at home, going to and from work, you might have a 40 kilowatt hour drain or up to even, 50, 60 kilowatt hour, depending on the size of the battery, probably 40 kilowatt hour drain going into the office. Come back home, that's nearly twice the load that you've already been doing daily in your house. So catching up, and Americans, we love having our own houses, we love having all of our own things, we love to make sure that you have every edge case solved, that now this energy is becoming a much more like complex or key piece of the equation in all sorts of ways. In New York, we're seeing the electrification of like ovens and stovetops, right? And that, while it seems minute in some respects, when everybody's cooking at 6 p.m. in Brooklyn, that's going to have an impact on the energy draw. And especially in the summer months when we're cranking our ACs and running the washing machine and our dishwasher at the same time, those peak rates start to stack up. And obviously, utility company can always make you pay more, but that energy's got to come from somewhere. And
Yeah.
battery developers are seeing the opportunity, and now I think we see more opportunity with the diversification of electric infrastructure too.
So put on your hat here, your magic hat. Where do you see this in 5 years if everything goes right?
If everything goes right, I see a balanced grid. I see an opportunity where we have more capacity developed from batteries, as well as supplemented by generation where necessary. But it's just a more holistic look at energy infrastructure. Um, Charging stations are going to be built, whether people like it or not, right? I think people will capture the opportunity, whether they succeed on the first go or whether it be the second go that they succeed on. It will be a long-term win, and that's how it's going to go. So making sure that we can supplement that with the right energy mix is really paramount to solving that issue. So optimistically, yeah, I mean, if I put my magic hat on, I think things go swimmingly. I think we start to honestly transition more towards a more diversified energy infrastructure. I talk with people just straight up on the energy storage side of things and what they're looking at for behind the meter storage and even front of the meter storage and how that interacts with everything there. One of the key considerations, especially on the U.S. side, is fiat concerns and the ability to get some of the incentives on that. That's foreign entity of concern. So effectively, you have to have 55% sourcing requirements for energy storage in the US, which now there's been some policy thrown around that needs to be up to 100%. There's nobody who's going to hit that for the near term, at least within this year. Coming into next year is more likely where we're seeing some of that target hit, but it becomes a very difficult thing. The fact of the matter is we need more capacity and we need to get capacity started in now, and we can solve our other problems later. But until we tackle that problem, everything else is just going to get more and more difficult as we compete for more of that energy.
And if I'm an investor or I'm building in this space, what's the one thing that I should understand that most people miss?
Real estate, number one. Real estate is number one in EV charging as a whole. But what energy storage helps to do and reflect back on that piece of things is make it more capable or more able to pick new or better real estate. So from that perspective, right, where power wasn't available before, if you bring a battery in and you drop it in, or you use GridLink in that matter, you can effectively power more. You can get into spaces that were harder to see. Gas stations become more viable. Gas stations are a nightmare to install in, actually, if you think about it.
Well, it
Yeah.
seems like the most natural place, right? I mean, it really does. I'm sitting here thinking like, why isn't it in every gas station already? Like it just seems like a no-brainer.
What's underneath the gas station is the question.
A lot of
Huge
gas.
fuel reserves. And then, complicated permitting procedures that have to go in place and how you're going to be digging around there, understanding what's below. And what becomes more viable is when you don't need to do a lot of new trenching and electrical infrastructure going in, and when you can kind of drop a battery on top and use the house power on 208 to power that up too. Uh,
Yeah, well, we saw the same thing with fiber capacity and bandwidth. It is very expensive to deploy that in complicated environments, generally concrete, right? Because you got to bore through concrete, and so like it was something as stupid as shopping malls weren't well wired because they've got a ring of concrete around them, and so you had a line in there from 1987, and that's about all you could do until we have satellite, reliable satellite and other stuff, but. It was really a challenge, and it's the same type of thing. Maybe I ought to go buy every piece of real estate next to a gas station.
Honestly, not a bad idea, especially if it's walkable and they can still use the conveniences of a gas station. Gas station probably happy on that because they're making a lot of their money off of convenience purchases anyway.
Yeah,
Uh,
I think if we've seen it around here. We have a large chain you probably know about, a Wawa, which is
yeah,
it's a similar to a Bucky's, and they've invested a lot of money with Tesla to make sure that, because they want those people there for 20,
yep,
30, 40 minutes. They like
yep.
those types of customers, and they have plenty of parking space to opt out of, to give into that stuff.
That's exactly it. And I think those types of convenience stores make a ton of sense. I've always been bullish on the strip mall theory. I've been incredibly bullish in what, Atish and I got going and was the hospitality industry and opportunities there. Hotels are at nearly every major intersection that you need along interstates and interstate corridors, but people don't think of it
And
as a
every
natural
rental
fit.
vehicle goes to where? Goes to a hotel.
Yep. Yep, exactly. They go to a hotel and rental vehicles, increasingly, that's where your first touch point is going to be with driving an electric vehicle in many cases. Outside of the dealership, which again, dealerships also make a lot of sense for battery integrated chargers. We have a bunch in Canada, as well as in the US that are running on limited infrastructure because that's what was available there, right? And they need a battery to help supplement that. So, I mean, I think we think about that, like from the other side of what people get wrong in that is really just understanding the power availability. So what I mean by real estate is it's picking the places that make sense, but also have the power availability or at least a pipeline to understanding when that power is going to get there and kind
Do
of going
do
from that.
we ran into this issue too, again, in bandwidth. I won't go too much into it, but there was limited visibility into where the networks were, believe it or not. Those networks have been strung up for decades and decades and decades. And, there were paper maps back in the day. Um, are you finding the same thing in the power grid as you go out there and it's supposed to be some capacity and it's not?
There's tools that are getting better. There's a few like data providers that we're able to utilize, and then also some free data resources that you can utilize for power capacity. I think a lot of times it does just come down to talking to the utility company when you kind of identify a site, you want to get in touch with them and understand what power is available in a nodal center around there, and kind of go about it that way. It's a lot of grit and grind and dirty work on it. But that's what makes things get done, right? And I think that's at the end of the day, you got to hustle to get things made.
Well, I tell you what, if I was inside of those power utilities as a marketing person, I would be doing that analysis and spraying that out to you guys of here's some, site ready sites that are, have capacity, are in, good areas, whatever you define a good area as, they could be real enablers in this.
Yeah, no, 100%. And some do, many do. Again, it comes down to that conversation though of who owns the land, right? So like if it's the right place and it makes sense, but the landowner doesn't want to deal with it, then they don't want to deal with it. And then you have to come and do an equation of what's the business model to then go and install chargers on there. Many folks will want ground rent. Some folks want revenue share. Some folks want to control the stack all themselves. And we've got partners that can operate anywhere along that scope. We can sell a charger outright to somebody if they want to operate it themselves and give them everything they need to operate that unit in and of itself. And particularly in the GridLink context from the energy management modes, right? Like we can help equip them with everything they need on that side of things. So it just comes down to the conversation, a lot of education, and kind of pushing it that way.
Yeah. Alex, fascinating conversation. We're wishing you guys all the best. It seems like a completely logical, approach to all of this. And we wish you all the best and congratulations again on the award.
Thanks so much, Russ. Thanks for having us.